Good morning, Mom. I am Nicolaus Dose from Bitibit FSM3B, and my topic is all about Nicolaus Copernicus. So, Nicolaus Copernicus was a Renaissance polymath active as mathematician, astronomer, and Catholic canon, who formulated a model of universe that placed the sun rather than the earth of its centers. Uh, One of the Renaissance men, particularly in the field of science, is Nicolaus Copernicus. Knowledge about the nature of the universe had been essentially unchanged since the great days of ancient Greece, some 1,500 years before Copernicus came on the scenes. This continued up to Renaissance period in one important way. Copernicus resembled the Greek ancient philosopher or thinkers. He did not anything extensive, just observing heavenly bodies or inviting people to test the ideas. Example of what is presently called as a thought experiment. By the time he finished his doctorate degree, Copernicus had been appointed as canon of Rome Park Cathedral in Poland. Despite its duty as a canon, he had plenty of time to sustain the interest in astronomy. Copernicus was strongly influenced by a book entitled Epitome, published in 1496 by the German author Johannes Moscheler. This book contains Muller's observation of the heavens and some commentary on earlier works especially that of Ptolemy. Copernicus' idea and model of the universe was essentially complete in 1510. Not long after that, he circulated a summary of his ideas to his few close friends in manuscript called Commentariolus, little commentary. The Commentariolus is Nicolaus Copernicus' brief outline of an early version of his revolutionary heliocentric theory of the universe. This was no proof that Copernicus was concerned about the risk of persecution by a church of which published his ideas formally. Copernicus was a busy man. His duty as a canon and a doctor affected his time formally to publish his work and advance his career in astronomy. The publication of his book, De Revolutionibus Opusculum, on the revolutions of the heavenly spheres, in 1543, is often cited as the start of the scientific revolutions. In his book, he wanted a model of the universe in which everything moved around a single center at unvarying rates. Gribun 23, 2003, Copernicus placed the sun to be the centerpiece of the universe. The Earth and all the planets are surrounding or orbiting the sun each year. The moon, however, would still be seen orbiting the Earth. Copernicus' model of the Earth orbiting around the sun automatically positioned the planets into a logical sequence. In his model, Copernicus outlined two kinds of planetary motion. One, the orbits of Venus and Mercury lay inside the orbit of the Earth, those closer to the Sun, and number two, the orbits of Mars, Saturn, and Jupiter lay outside the Earth orbit, those rather than from the Sun. From this model, he worked on his length of time it will take for each planet to orbit once around the Sun. The result would form a sequence from Mercury, with a shortest year, through Venus, Earth, Mars, Jupiter, and Saturn with the longest year. He placed the planets in order of increasing distance from the Sun. One of the great problems in the Copernicus model, however, was the position of the stars. The star cannot be placed in a fixed position like crystal in distant sphere. Copernicus is also a courageous man. Although the Copernican model makes sense now, during those times, it was judged a heretic and therefore it was an unacceptable idea to be taught into Catholics. The Catholic Church banned the Copernican model and was ignored by Rome for the rest of the 16th century. Who proved the heliocentric theory? So Galileo. Galileo discovered evidence to support Copernicus' heliocentric theory when he observed 4 months of orbit around the Jupiter. How did Nicolaus prove his theory? Copernicus' observation of the heavens were made with the naked eye. He died more than 50 years before Galileo became the first person to study the skies with telescope. From his observation, Copernicus concluded that every planet, including Earth, revolved around the sun. Why did Copernicus fail to prove that the Earth revolves around the sun? So the heliocentric model was generally rejected by the ancient philosophers for 3 main reasons. If the Earth is rotating about its axis and orbiting around the sun, then the Earth must be in motion. However, we cannot feel this motion, nor does this motion give rise to any options observational consequences. And that's all my part, and thank you for listening.